comparison test. We're going to let the series be a sum of positive terms if Bn is convergent and Bn's always bigger than An, then that sum is also going to converge. It's dominating it. All of its terms are bigger, and it adds up to something. So the one with the smaller terms has to add up to be something too. What else? What if your series that you're testing has a series that has smaller terms for every term, and that series of smaller terms doesn't add up to anything? Then the one above it can't either. That's the idea. Let's perform the calculation. Boom! The comparison test. We have this sum and we're trying to show that it converges or diverges. You first have your initial inkling and you're like, I think that that diverges. Why? Because you're trying to compare it with a p-series, a known diverging p-series. But anyways, we think that's going to diverge, so we need to get under it. So you look at the underlying sequence in that series. There's that An right there. Boom. I'm comparing it with this guy. Why? Because I have a lot of experience, and I'm wondering which fraction's bigger. Is the fraction on the left bigger, or is the fraction on the right bigger? The one on the right has a bigger denominator. If it has a bigger denominator, then it's smaller. Yeah. So then, boom, that one is smaller. But that guy is a divergent p-series. So since we have it bounded below by a divergent p-series, and that one diverges, then so does the one that's above it. And that's the comparison test. Box and flower.